Now let's take a look at a different way that the information could be given to us to calculate probabilities. So we're going to look at contingency tables. So a contingency table is a table that's used to organize the results from a survey where each respondent was asked 2 questions. So here we have an example of a large group of friends that were getting together for game night. They decided to take a survey of each person and ask them which game they wanted to play and what snack they wanted to have while playing that game. Each person could only choose one game and one snack. So they weren't allowed to say, oh, I want pizza rolls and cookies. You gotta pick one. So the results of the survey are shown in the contingency table below. So we have the 3 snacks that they could choose from: pizza rolls, chips and dip, or cookies, and 4 possibilities for the game: poker, Trivial Pursuit, Monopoly, or Wii Bowling. And then we have the total for each row and each column, telling us how many people voted for that snack and then how many people voted for that game. And then on the inside part of this, we see how many people voted for that game and that snack. So for example, this first guy here, I'm going to circle it for a minute and then I'm going to erase it. 10 people said they wanted to play poker and they wanted to have pizza rolls while playing poker. That's what that number represents. So first question we're going to solve with this table: find the probability that a randomly selected person wants to play poker. So we're looking just for people that want to play poker. So the probability of poker is going to be the total number of people that want to play poker. So I'm going to find poker. I'm going to go to its total. There are 25 people that want to play poker, divided by the total number of people in this survey, which is always going to be the bottom right number if you have total columns. So there are 115 respondents in this survey. Always make sure we give our probabilities as decimals, rounded to 4 decimal places. So this is 0.2174. Find the probability that a randomly selected person wants to have cookies. So I'm going to solve this in a very similar way. I'm going to go to cookies, and I want to find the probability of cookies. So how many people total said they wanted cookies? 30 people wanted cookies. And there were 115 people invited to this game night. Oopsies. Oopsies. I keep typing in the wrong numbers. And that's 0.2609. So the probability that someone wanted cookies is 0.2609, or roughly 26% of the people voted for cookies. Find the probability that a randomly selected person wants to play Trivial Pursuit and have chips and dip. So now we're not just looking at one row or one column like the first 2. I'm looking for someone who wants to play Trivial Pursuit and they want to have chips and dip. So for this one, I'm looking for Trivial Pursuit, which I'm just going to shorthand to trivia, and then chips and dip, C and D. I just don't have a ton of room to write. So to find this one, I'm going to look for how many people voted for Trivial Pursuit and chips and dip. So it's like the overlap between that row and column. So here are the responses for Trivial Pursuit. Here are the responses for chip and dip. Wherever they overlap, that's the and. That's how many people wanted both. So 14 people out of the 115 total voted for chips and dip and Trivial Pursuit. and that's 0.1217. Actually, I'll keep that circled. So now, find the probability that a randomly selected person wants to play Monopoly or have pizza rolls. So we're looking at playing Monopoly or having pizza rolls. So when we see one of these problems, we need to ask ourselves first, is it possible for someone to have said Monopoly and pizza rolls? Is there any overlap in these results? And when you have a table like this, there is always going to be overlap. If one of the things you're looking at is in a row, like Monopoly is a row, and the second item is one of the columns. Pizza rolls are a column. There is overlap. So these are non-disjoint events. So we're going to find the probability of Monopoly or pizza rolls. I'm going to shorthand these again. By first finding the probability that people wanted to play Monopoly. So I'm going to find the total probability of selecting someone who wanted to play Monopoly. 38 out of the 115 kids, I'm assuming kids, wanted to play Monopoly. Then I'm going to add the probability of somebody wanting pizza rolls. So there were 44 out of the 115 kids wanting pizza rolls. So first I found this guy, Monopoly by itself. Then I looked at, okay, what about pizza rolls by themselves? Now we've double counted people, so we need to subtract off the probability of somebody wanting both of them. And there are 14 people that voted for Monopoly and pizza rolls, where they cross, where that overlap happens. So 38 plus 44 minus 14 is 68 over 115, which is 0.5913. So if I have all of these people in the room and I point at one person and I say, "Oi, did you vote for Monopoly or pizza rolls?" There is a little over a 59% chance that that person's going to say, "Yeah, I voted for one of those. Doesn't matter which one to me right now. I just want to know, did you vote for one of those or both of those?" Okay. So last example. What is the probability that a randomly selected person wants to play Wii bowling, or have cookies? So we're looking at Wii bowling or having cookies. So again, one of these is a row, one of these is a column, so there is overlap. So we're going to have to subtract off the overlap from the totals. So the probability of Wii or cookies is first going to be the total number of people that voted for Wii. So 23 out of the 115 people voted for Wii bowling, plus 30 out of 115 people voted for cookies, and 4 people voted for both. So those 4 people were counted as part of the 23. They were counted again when I looked at the 30, and they only count as one person. So we have to subtract off the 4, otherwise we have a double counting situation. So this is 49 over 115, which is 0.4261. So these are some different probability examples when you are presented with a table like this.